Hello there, my name is Nicholas Baranaga and it is February 12th, 2026. In this Mark II version of my Telegram, I'm going to actually give you the demonstration first and then I'm going to explain the differences between Mark II versus Mark I. Really quick, the one sentence of what this project is it's a embedded C program on a microcontroller that is creating the functionality of a Morse code telegram. Essentially, I wanted to create a telegram and my hope is, and it's succeeding, sending messages from my breadboard to my computer and then eventually sending that message all the way to somebody else's computer. So here's the hardware, here's the software. You'll see I have two programs, main.cpp, which is more of a helper, and then my actual firmware, AVRC and AVRH. I'm just going to do that demonstration and then we'll talk about more detail afterwards. And I really want to talk about the MCDB, which is the Morse code data buffer that I designed. Okay, so when we launch the CPP program, you probably hear there the firmware being flashed. I just made it so that this buzzer will go off when the firmware is being flashed. And you'll see on the screen two separate streams for Morse and English. I'm going to just type out hello world, and then we'll talk about it. So you'll hear the different lengths, noise lengths. I added that since Mark. I guess I can almost talk about the differences as I do it. So I added this buzzer, which is going to give us different tones for short dashes, long dashes, and transmissions. And you'll hear the difference in those lengths. And you're also going to notice that after each transmission of a letter, the Morse code stream is going to actually display with a space in between each one. So you can see there is a space here and a space there. And what we will also see is that between words, we'll get delineators. There's some of those longer tones for the long input. So I found that the dot, dash, sign was not used by any English letter, so I'm using that for space. And so you can see I added a delineator there as soon as that happened. And now W is going to be dot, dash, and you're going to see in the English, after doing this character here, in the English stream, we're going to actually see a space now. And here we see a delineator. Those are basically just supposed to be the equivalent. So you see now we have a new word starting. So we're going to do the O and the R. I'm actually going to probably, I think I can finish it up quickly. Okay, well I misspelled it, but that's fine. So the differences between this and Mark I is now I've added both those programs, the C++ program, which actually runs a bash script to flash the firmware onto the microcontroller, and then is doing this nice little visual separating the streams because both of these Morse code streams and English streams are actually being spat out over the serial port at the same time. What else did I do? I added these delineators. And then what I really want to talk about is the Morse code data buffer. So if you want to see that, what I'm talking about, you can go into the repository and look at avr.c or avr.h, or in the repository under project documents, I'm going to very soon add a diagram with maybe a little bit of writing talking about what the MCDB is. So essentially, in order to translate Morse to English, I'm using 1 byte. Now, Morse code, kind of like binary, has two conditions, either short dash or long dash. So you could easily map that to 0 and 1. However, not every Morse code value is going to be the same length of digits. Sometimes it can be anywhere from 1 to 5. And the problem is how do you tell in a binary number whether 0, if we're doing zeros as short inputs and ones as long dashes, how do you tell if it's off, if it's no input, if it's just a null character? So what I'm doing is not necessarily novel, but I think it's good design. I'm using 5 of the bits in the byte to actually be data bits. They're actually translating, imbuing meaningful data. The other 3 remaining bits, the most significant bits, I'm using to tell myself in the program how many of the bits in this byte at the time to actually expect to be meaningful, to actually even pay attention to. So there's going to be 3 bits. 2 to the 3 is going to give you 8 potential values. I don't actually need all of those 8 because I only have 5 extra bits. And so all those 3 bits need to tell me is 0 to 5, how many of these bits in the buffer are meaningful. And that's how I'll have it in the documentation so you can read it, but that's how I'm achieving that. And I think it's kind of a clever way to do it. Anyways, I will make a video when we're at Mark III, but I'm about to run out of time. Thank you.